Factoring out a greatest common factor. A prime number is a whole number that is only divisible by itself and 1. An example of a prime number would be 17. Composite numbers have whole number factors other than 1 and the number itself. The prime factorization of a number is the unique way of representing numbers as the product of their prime factors. And the greatest common factor of numbers is the greatest integer that divides without a remainder into the numbers. So we'll start by showing you the prime factorizations of two numbers, and we'll use a factor tree to show where these prime factorizations came from. We can represent 120 as 10 times 12. The number 10 can be written as 2 times 5. 12 can be written as 2 times 6, and 6 as 2 times 3. None of the numbers that remain can be broken down further because they're prime, so we can write 120 as 2 times 2 times 2 times 3 times 5. 924. This number is divisible by 4 because the last two digits form a multiple of 4. 4 is 2 times 2. 231 is divisible by 3 because the sum of the digits is a multiple of 3. 77 is 7 times 11, and we can write 924 as 2 times 2 times 3 times 7 times 11. Now let's determine the greatest common factor of these expressions. Let's represent both terms in example A as their prime products. And now let's look for common prime factors. We'll circle them. And now we'll write the greatest common factor as 2 times A times A times B times B. But we'll learn to use the exponent form. It'll be more helpful for us. Example B, same thing. Here's the first term, here's the second term. We'll circle the prime factors, and we'll write the greatest common factor as 2 to the second power times C to the third times D squared times E. So notice the direction was to determine the greatest common factor of the expressions. It did not say factor the expressions, right? It just said determine the greatest common factor. All right, now we will have directions that say factor the polynomial like these two. We'll start by identifying the greatest common factor, and then we're going to divide the given polynomial by the greatest common factor. We can divide that using mental math, using reverse distributive property. I'll use the box strategy. Here's the original polynomial. I'll write the greatest common factor over there, and I'll think 2x times what is 6x cubed? 2x times what is 8x squared? And 2x times negative 1 is negative 2x. And for your final step, you have to rewrite the original polynomial as the product of two factors. And here we've done that. So when the directions say factor, it's important you know we want to rewrite the polynomial as the product of two factors. All right, example B, the greatest common factor is 9x to the fourth y squared. That's the biggest factor that will go into both terms evenly. And again, we'll divide by that greatest common factor, and we will rewrite our polynomial as the product of two factors. So the direction there, when it says factor the polynomial, remember you want to write it as a product of factors. Right, now when it says simplify expressions, usually a common factor will eliminate or cancel out or divide out. So we'll notice the greatest common factor of the numerator is 3. We can factor the numerator. Now we can cancel out a 3 in both numerator and denominator because 3 divided by 3 is 1, and 1 times p plus 1 is just p plus 1. So notice we've taken the original expression and we simplified it by dividing out a greatest common factor. We'll do the same thing in the second example. We'll rewrite our numerator. We will divide both numerator and denominator by that greatest common factor, leaving us with a fraction 1 minus 5x over y. We'll take a word problem. Here we're told that a certain expression, which is a polynomial, negative 16t squared plus 17t plus 12, can be used to represent the height of an object launched into the room from 12 feet off the ground with an initial velocity of 72 feet per second. We're asked to rewrite the formula by factoring the right side, using the GCF, and by making the t squared term positive. So looking at that expression, which is made of 3 terms, they don't all have a t, but they do all have numbers, and the greatest common factor of the 3 coefficients is 4. But I will factor out a negative 4 because that's how we will make the t squared term positive.